Hello, my Math 3 scholars. Today we're going to be looking at bisectors and triangles, but before we look at that, we need to talk about a few definitions that we make sure that you understand. So the first definition I'm going to give you is the word concurrent. And that word just means you're going to have three or more lines that intersect at one point, okay? So we might have lines that do that, and they intersect at this one point here, okay? So it's a concurrent point, and we actually call it a point of concurrency, is when three or more lines intersect at one point. And that's the next definition, actually. The point of concurrency is the point where they intersect. So this point where these three lines intersect here, that is our point of concurrency. That's our point of concurrency. And then the other word is the circumcenter of a triangle. The circumcenter of a triangle. And that is the point of concurrency of the perpendicular bisectors for a triangle. Now, we've talked about perpendicular bisectors. Perpendicular bisectors is where it creates a 90-degree angle, the bisector does. And so when you have three of those in one triangle, and they cross, those three lines cross in one point, that point is called the circumcenter. Okay. Now, I have a theorem down here to share with you, and that is the concurrency of perpendicular bisectors theorem. And this is what it says. The perpendicular bisectors of the sides of a triangle are concurrent at a point that is equidistant from the vertices. Okay. So what that is saying is this. So we've got our perpendicular bisectors here that cross. And you can see this is labeled, here's a perpendicular bisector here and here. So all of these lines, this line, and this line, they are perpendicular bisectors. And they meet at this point right here that we have labeled as point P. Okay? So that point P there, that point P is the point of concurrency, and that is also our circumcenter. Okay? So they are concurrent at that point. Now, in symbols, what that means is this. If we have perpendicular bisectors, PX, PY, and PZ, and they are concurrent at point P, that's where they cross at, that's where they intersect, then what this theorem tells us is that this side here, PA, is equal to this side here, PB, which is also equal to this side here, PC. They are equidistant from the vertices. So these three lines are going to be equal to each other. This line, and this line are going to be equal to each other. Okay? And I also put you a little note here that the circumcenter of a triangle can be inside the triangle, it could be on the triangle, or it could also be outside of a triangle. And in this next definition down here, I've kind of drawn you a picture of what that might look like. So if you have an acute triangle, now just to remind you, an acute triangle is a triangle that has three angles that are less than 90 degrees. It could be an isosceles triangle or a scalene triangle. And you'll notice that when you have an acute triangle here, we've got that drawn that our circumcenter is inside the triangle there, okay? For a right triangle, most of us know what a right triangle is. That has one 90-degree angle, like this. It has a 90-degree angle. And when we draw those perpendicular bisectors, that one, you can see that in this drawing, it is actually on the triangle, is where they cross at. And then an obtuse triangle, if we have an obtuse triangle, that is a triangle that has one angle that's greater than 90 degrees. So one of your angles is going to be greater than 90, and that could be an equilateral triangle, an isosceles triangle, or a scalene triangle. So one of your angles is going to be greater than 90 degrees. And you can see here that time our point is on the outside of the triangle. So the circumcenter of a triangle can be inside, or it can be on, or it can be outside of the triangle. So let's just look at an example here of what we are talking about and how we would use this. So what are the coordinates of the circumcenter of a triangle with vertices? And we're going to label these on this chart over here, on this coordinate plane. So we have point P at 0, 6. That's point P. We have point O at 0, 0. And then we have point S at 4, 0. So we have a triangle that looks something like this, okay? Now, in order to find the circumcenter, if you think about it, what you're doing is you're drawing a line here, okay? You're drawing a line from here. You're also going halfway here and drawing a line. So we're going halfway here. That would be this line here. And then we're going halfway up and down here. 1, 2, 3, 4, 5, 6. So halfway would be here at this 3 point. So it looks like our point is right here. It looks like it's at 2, 3 is where our midpoint is going to be, or our circumcenter. But the way we can actually find that is by finding the midpoint of this line here, PS. So we want to look for the midpoint of PS. Now, in case you have forgotten your midpoint formula, let me remind you that the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 divided by 2. And that x1 and x2 and y1 and y2 come from these coordinates here. And since we're looking at P and S, we're looking specifically at this coordinate and this coordinate. So I'm going to label this as x1, y1 and x2, y2. And we're going to plug these numbers into this formula and find that midpoint. So x1 is 0 plus x2 is 4, and it's divided by 2. And y1 is 6 plus y2 is 0, and it's divided by 2. All right, 0 plus 4 is 4. 6 plus 0 is 6. And then that means our midpoint would be at 4 divided by 2, which is 2, and 6 divided by 2, which is 3. And that's where we thought it was going to be. So our circumcenter here is at 0.23. So this equals our circumcenter for this triangle. That is our circumcenter of the triangle. Okay? Let's work one more of those. So what are the coordinates of the circumcenter of a triangle with vertices 2, 7, 10, 7, and 10, 3? So let's label that. 2, 7. That's point A. And then point B is at 10, 7. That's my B. And C is at 10, 3. So 1, 2, 3. All right, so we have a triangle that looks like this. And again, I'm not drawing that very straight there. All right, so here we can tell we have 1, 2, 3, 4, 5, 6, 7, 8 lines between there. So that means I'm going to go halfway. 1, 2, 3, 4. So that's going to be right here is that one line. And then here is 1, 2, 3, 4. So half of that would be 2. So this line's going to be here. So it looks like my point is right in here somewhere. So I need to find that midpoint of A and C. So I'm looking for the midpoint of AC. Okay, that's what I'm looking for, the midpoint of AC. All right, so that means I'm using this one and this one. So if we label this x1, y1, x2, y2, okay, we add our x's, 2 plus 10, and divide by 2. And we add our y's, 7 plus 3, and divide by 2. All right, that gives us 12 over 2 and 10 over 2. And then when you simplify that, that would be 6 and 5. So this is our circumcenter for this triangle. Is at 6, 5. And which you can see here, 6, 1, 2, 3, 4, 5. That's where we had it there, 6, 5. That was roughly where we thought it would be. All right, guys, as always, if you have any questions, let me know.